Hey, and welcome to the lesson where we'll be talking about exponential decay. So what is exponential decay? It's actually very similar to exponential growth, except for now, instead of increasing over a certain amount of time, um, the starting amount is going to be decreasing at a certain rate over a certain amount of time. So by the end of the lesson, you should be able to introduce exponential decay and model exponential decay with exponential equations. So, exponential decay, you'll see that there's still a principal or starting amount, there's still a certain amount of time, and there's still a rate. The big change here is right here, this minus sign. That is the difference between exponential growth and exponential decay. So, if you think about it, exponential growth, if you think about a bank account, if it's increasing 3% every year, or let's just say 10%, if it's increasing 10% every year, that means you're going to have whatever your starting amount was plus, so you're going to have that, so times 100%. Right, which is just 1. So 1.0, right? If we change that into a decimal, 100% would just be 1.00. And so I know I'm going to have 100% of what I had in there. And added to that, of what I had in there to begin with, added to that, I'm going to have a certain percentage of it, so 30% of what I had in there. Let's say I changed it to 30%, but whatever your rate is, 30% of what's left in there. So, or what I started with. So what I started with times 30%. I'm gonna write that as a decimal, 0.30. If I factor out the common term here, which is the principal, I'm going to get P equals 1.00 plus 0.3. And that is exponential growth. It's 1 plus my rate, which is right here. If I think about exponential decay, I'm going to have my starting value, and they're going to take out a certain percentage. So I have to take away from that starting value now, and so I'm taking away a certain percentage. Okay, so now if I factor out the common principal, I have 1.00 minus 0.3, or whatever my rate is. And so that is exponential decay. So decay, decrease. So think about it that way, and growth, increase. Think about it that way. And so here is growth. Let's just do an example problem real quick. Oops, get my pen back. So a $35,000 car decreases in value by 10% every year. Okay, well, so the starting value of the car is $35,000, and it's going to decrease at a rate of 10% every year. Write that as decimal, is 0.1. So what is the value of the car after 10 years? So now my T after 10 years is going to be 10. And so what is the value of the car? So 35,000 times 1.1 to the 10th power. I'm sorry, I didn't realize this, but I didn't subtract, I added. Made a little tiny error there. So it should be 1 minus 0.1, therefore 0.9. And if I do that calculation, 12,203.745. And I'm going to round that up because I can't have part of a penny. So after 10 years, a $35,000 car, if it decreases, if the value decreases 10% every year, the value of the car would only be, after 10 years, it would only be $12,203.75. So that's exponential decay. Go ahead, try your assignment. If you have any questions, reach out to me. I'll be in Math Cafe at 11 a.m. Monday, Tuesday, and Wednesday. If you have any questions, if that doesn't work for you, there's always a teacher in there from 9 to 3 every school day. If you have any other questions, come see me in live class. Watch the live class recordings if you can't make the live class, or just email me, text me, BBIM, whatever's easiest for you. And make sure you join us for the next lesson on logarithmic functions.